Okay. Right, good afternoon and welcome. JDK 12, Pitfalls for the Unwary. I'm not actually sure if that's the title that was advertised. It might have been JDK 11, but you know, Java's moving so quickly at the moment, and I thought I'll update it. I always like to start these sessions with a little poll of the audience. So if we think about production systems, who here is using JDK 8? Okay, very good, as I expect. Anybody here using JDK 7? Nobody. Anybody 6? I'm guessing that. Oh, one person in the back there. Okay, interesting. Okay, let's move forward. Anybody using JDK 9 in production? Nope. 10? 11. Ah, interesting. Good number of heads. Anybody using 12 in production? Ah, some keen people there. Okay. So the idea behind this presentation is I have tried to collect together absolutely every single thing that I can find that would possibly trip you up in terms of moving your application from JDK 8 or earlier to JDK 9, 10, 11, 12. Clearly, if you're thinking about moving your application from JDK 8, do not think about using JDK 9 or 10, because they're feature releases, they have no more updates. 11 is a long-term support release, 12 is a feature release, but yes, you might want to keep up with the pace of change. So, absolutely every single thing I can find that could be a problem. So obviously, the way that we have to look at this is in terms of the functionality. And so I have created this very complex Venn diagram here that demonstrates the changes in functionality. Obviously, it's not strictly speaking correct, although it's pretty close, because obviously we add new features to each release, but there are a few things that get removed as well. And that is one of the things where we can find that there's an issue in terms of when things get removed and you've been using them, how do you cope with that in your application? Right, let's start with JDK 9. Now, this is going way back in Java history, all of, let's see, 18, 19 months. And this was really a significant release of Java in a number of different ways. It is, as Oracle describe it, the last major release of Java. And what they mean by that is the last release that has several years of development effort involved in it. What we've seen, as I'm sure everybody is aware here, is a change to a much faster release cycle. Now we have 2 releases a year. Every 6 months, we get a new JDK, and that's in March and in September. So JDK 9 contained a lot of changes. Most of them, it has to be said, were fairly small. A lot of them were quite low level in terms of the JVM itself or buried in the libraries, so they didn't really have too much impact. But there was one which is really quite significant, and so we need to spend at least a couple of minutes talking about that. And that is, well, okay, before we do that, let's talk about compatibility. Right, so the fact that JDK 9 was a big change wasn't just because of it being the last major release. It was also because Oracle made some decisions around the fact that they wanted to start cleaning up the JDK. Over the sort of 25 years of history of Java, lots and lots of things have been added. But until JDK 9, pretty much nothing had ever been removed. And that was a problem because it was just too much of a build-up of technical debt. The number of things that Oracle engineers were having to continue to support and make sure that security issues and so on were resolved was just too big. And a lot of these features were just things that were so niche in terms of the people that were using them that they really said, okay, it's time to have a cleanup. And the effect of that is that compatibility is changing. In the past, for Sun and then Oracle, compatibility has always been a very big thing. The fact that you can take an application that was written in JDK 1.2, compiled on that JDK, and you could run it on JDK 8 without any changes. That was a great thing because you didn't have to spend time modifying your code to make it work when it already worked. There were a couple of things along the way, minor issues in JDK 1.4 and JDK 5, the introduction of some new keywords. So 1.4 introduced assertions, so assert became a reserved word. In JDK 5, we got enumerations, and so enum became a reserved word. But they were fairly simple problems. I mean, global search and replace, fairly easy to get around those things. Deprecation was another thing that was introduced in JDK 1.1. And this allowed the engineers to say, these things, these APIs or features, are things that we think should be removed at some point in the future. Either they are things which we think, OK, we actually got it wrong, in the case of some of the thread methods, that was a good example, or there are things where they've replaced it with a newer version which is better. So if you think about like string buffer and string builder is the better version. You know, array list, you should be using it rather than vector, things like that. So JDK 8, I added it up, had 492 deprecated API elements in it. So that's interfaces, classes, methods, and so on. And of those, none, as I said, had ever been removed. The other thing that Oracle said was that they would be very generous and they would give us at least one release warning of a feature being deprecated and then being removed. So that's very generous of them, because less than one release warning would be no warning at all. So the thing about that is that we could potentially have a feature that disappears in 6 months. Deprecated in JDK, I don't know, 13, removed in JDK 14. That's quite possible. So as I said, JDK 9 is all about starting a cleanup of the JDK and the Java platform itself. Things are now being removed as well as added. And this is carried on in JDK 10, JDK 11, JDK 12. So Mark Reinhold was here today, and this is a quote from him from one of his presentations. He says, if your code only uses standard Java SE APIs, then it will most likely work without change. Now, clearly that's not quite as reassuring as you would like. You would like to see it will just work without change. But in this case, because of the fact that we're making changes, removing things as well as adding things, it's now most likely that it will work without change. And really, the rest of the presentation is about what is going to be the things that will cause it not to work without change. So the module system, let's talk a little bit about that. I don't want to spend too long on it, but it does have implications, and it certainly is an issue when it comes to migrating applications from 8 to 9 or later. The module system was really about two things. The first was taking the monolithic rt.jar and tools.jar files and breaking them up into more manageable units. Again, if you look at the history of Java, you go all the way back to JDK 1.0, what you would find is that there are 211 classes, public classes, in JDK 1.0. Move forward to JDK 8, and there's somewhere over 4,500 public classes. That's very good for us as developers, because we don't have to write our own array list class, we don't have to write our own semaphore class, and so on. They're all there for us. But by adding them all to a single jar file, it becomes very unmanageable, unwieldy, and also from the point of view of the runtime, you end up with a very large runtime that includes lots of stuff that you're not actually using. So modularity was about breaking this up into more manageable pieces. We've seen this in the past with Java. I mean, right from the very beginning, we had a way of grouping classes together into a package. So a module is just a way of grouping packages that are related into a module. What we end up with is 24 modules that are required for Java SE, so that's the standard defined by the JCP through various JSR. There are two what are called aggregator modules. Aggregator modules are ones which only contain references to other modules. They don't contain any packages themselves. Bizarrely, there's one smart card module that gets included in Java SE. That's a sort of historical thing, just happens to be there. And then there are 48 that are specific to the JDK, which are things not in the standard, but related to other parts of the JDK, like the compiler interface and various other bits and pieces like that. If you look at the Oracle JDK, there are another 14 JDK ones. There's also JavaFX, which is 8 modules, and then there's 2 Oracle-specific ones as well. So that's actually reasonably simple to deal with. The fact that we've just broken up rt.jar into modules, not really too big a problem. The other thing, which is more of an issue, is that the developers wanted to encapsulate the internal APIs. If you look at rt.jar, there's 4,500 public classes, but there's also a lot of internal classes, ones that you're not supposed to use. Sun, misc, unsafe being the most obvious of those. So anybody here use sun, misc, unsafe? A couple of people. Okay, anybody here use a third-party framework or library like Spring or Log4j, anything like that? Yes. Okay, so you are using sun, misc, unsafe, you just don't see it obviously. And what the developers wanted to do was to hide all of those APIs because it was potential security issues, potential maintenance issues, all sorts of things like that. And they said, right, we're just going to encapsulate all those internal APIs. That wasn't going to work because too many people use frameworks and libraries that do use things like sun, misc, unsafe. What the decision was made was that they would actually allow you to continue to use these through some command line options, and we'll explore that in just a moment. So how do you migrate to the module system? So the simple answer to that is leave everything exactly the same as it was before. Having modules in the JDK itself is good, but it doesn't mean that you have to use modules straight away in your application. You can start by leaving everything on the class path. If you do that, all the things that you leave on the class path become part of what's called the unnamed module. And this is a module that is simply there by default. It's sort of invisible. You don't need to worry about it from the point of view of development or deployment. How that works with the rest of the module system is that all the packages that you have, public packages on your class path, are exported to everything that's on the module path. And the dependency of the unnamed module is on everything that is on the module path. So there's a two-way integration which makes life very simple. What you can then do is you can migrate gradually to modules if you want to. Again, quick show of hands. Anybody here using modules for their application? Wow, okay, that's interesting. Yeah, because I was talking to somebody from IBM about this today, and we were saying, we haven't seen many people actually modularizing their application, and that shows that's quite true. So what you can do is you can migrate jar files from the class path to the module path. You don't have to change them, you simply move it from the class path to the module path, and it becomes an automatic module. Automatic module is one that doesn't have the moduleinfo.class file in it, so it doesn't have specific information. Everything is derived directly from the jar file. The name of the module comes from the name of the jar file. All of the public classes are exported from that module, and all of the other modules on the module path are a dependency for that module itself. And then if we look at that in terms of a diagram, what we can do here is we can say, okay, so we leave everything on the class path, all our jar files are located there, and everything will work by having dependencies on everything that's on the module path. In terms of gradual migration, we can simply move our jar file and not make any changes to it, take it off the class path, put it on the module path, and it becomes an automatic module. If we then want to take the next step, we can then rebuild our jar file, include a moduleinfo.class file which has specific information about which packages are exported, which modules it does have a dependency on, and you can then create a proper full module from that. Now, I said about encapsulation and the fact that this is it's possible to avoid the problems of that. So one of the things that was introduced was the wonderfully named big kill switch as a command line option. And it has the wonderful name of illegal access. So you look at it, you go, ooh, illegal access. What this allows you to do is determine what happens when you try and access one of the internal APIs of the libraries itself. By default, the option that this is set with is permit, which means that when you try and access one of the internal APIs, the first time you access it, you will get a warning message printed on the standard error. If you want a bit more information about how much you're using these things, then you can change the setting and you can say, give me warnings. Every time you use an internal API, you will get a warning message on the log, the standard error output. If you want even more information, you can set it to debug, and that will give you a warning message every time you use an internal API, but it will also give you a stack trace, and that way you can see where you came from in your code to get to that point. And then the fourth option is where you can just turn everything off and say, I don't want access to the internal APIs. The idea is that at some point in the future, this will become the default. It is not clear when that's going to happen, certainly probably not anytime in the near future. You can also, rather than reversing encapsulation in a sort of global way, you can do it in a more fine-grained way. There are two ways of doing that, through two options, add exports and add opens. Add exports allows you to specify that there is a package and a module and a package that you want access to. And you can say, in this case, Java management is the module, and the com/sun JMX remote internal is the package, and I only want my test module to have access to that. And so I can restrict its access. If I want to allow everybody access to it on the class path, then I can do the same add exports, specify the module as Java management, specify the package as sun management, and then say all unnamed. And that will give everybody on the class path access to that internal API. So that's for importing a class or a package through the import mechanism. If I want reflective access, then I can do the same thing but use add opens, and that will grant me reflective access rather than import access. Same thing, add opens, name of the module, java.base, name of the package, java.util, and again, all unnamed, everybody on the class path. To make life even simpler, if you want to set things up so that you can provide a jar file to other developers and not have them have to set up things on the command line, you can include in the jar file manifest the same essential information. So you can do add exports, java.base, sun security provider, and that will grant access to the packages in that jar file without you having to specify anything on the command line. So that's a nice thing if you're actually providing a jar file to other developers. Another useful tool that's been provided from JDK 9 is the idea of finding the dependencies that you have on other packages, other modules, and so on. So there is this command called jdeps. And I have to say that in JDK 9, it had a few kind of rough edges. From JDK 10, they've done a bit more development work on it, and it is a little bit nicer now. In this case, what I've got is a simple example here where I've said, OK, I want to find out the dependencies of a particular jar file that I have, which is called flight tracker. I'm going to give it the module path as to where to find the modules. And I'm going to say that the modules that I want to add are this particular thing. And then what I'll get is an output about the various things that I've been using. So there's some warning messages there about something that's been removed in terms of JarFX. And then we've got a list of the modules that I'm using, java.base, data transfer. Interestingly, it sort of breaks up desktop into multiple things. And I don't quite understand why that is, but it does. And then you've got Java logging, scripting, SQL, XML, and so on, plus other things as well. So it gives you a whole list of all the things that you're dependent on, so you can think to yourself, OK, what do I need to do? Do I need to change anything in terms of my application? Missing modules. OK, so this whole thing about, most likely will work without change. One of the aggregator modules is java.se.ee, slightly bizarre naming of the module. But essentially, this is a number of things which have been added to Java SE from the enterprise side of Java. And so that was an aggregator module that had 6 modules that it referenced. From JDK 9 and JDK 10, in both compilation and runtime, you wouldn't be able to use this aggregator module by default. So from JDK 9, when you compiled code, it wouldn't be added by default. And when you ran an application, even if it had been compiled with these modules, they wouldn't be included by default. So you would see error messages straight away. The modules that are affected are Corba. Anybody here using Corba? Nope? OK, good. Activation framework, that's part of Java Beans. The JAX-B, Java API for XML binding. Anybody using that? Oh, a couple of people, right? And the one that does seem to catch out quite a few people is JAX-WS, web services. But that's the SOAP-based way of doing web services rather than RESTful web services. Who's using JAX-WS? Ah, OK, interesting. Less people than I expected. But anyway, so these are modules that will not be included by default. In terms of getting around that, in JDK 9 and JDK 10, it was reasonably easy because you could simply add the modules on the command line, whether it's compilation or actually at runtime, because they were still there. In JDK 11, they've actually been removed completely, so you need to find an alternative source of those. In the case of everything except Corba, you can go to Maven Central, there are modules, you can just update your POM file, and you can get it through there. There's also the access you can get through the JSR for each of these. There's a reference implementation, you can do that. You can deploy standalone versions through what's called the upgrade module path, and you can specify where those modules can be found, and then you can link into those and everything will work without any problem. Or you can just simply take the jar file and put it on your class path and do the same thing. Small incompatibilities with JDK 9. Okay. One of these was a slightly bizarre change, which is that the single underscore in JDK 9 became a keyword in Java. Anybody here use a single underscore as a variable name? No, okay, interesting. So as of JDK 9, you can't use a single underscore as a variable name because it's being reserved for future. At some point, Lambda expressions will use a single underscore so that you can hide, in effect, a parameter that's not used in the body of the Lambda expression. So that's the reason why they changed that. I did check this, and it turns out that if you really do want to use a single underscore, you can use 2 or more underscores, and that will still work quite happily. I don't recommend that as a variable naming scheme, but you can do it. The other thing with JDK 9 was that they actually did remove some of the deprecated methods. And they didn't exactly go overboard with JDK 9. They removed 6 methods. That was it. So if you look, there's jar pack200, unpack200, and logging.logmanager. Both of these had 2 methods removed, which is add property change listener and remove property change listener. I doubt very many people here have used those. The reason these 6 were removed, because you have to think, what did they do that was so bad, was when they tried to separate out the rt.jar into all these modules, they found some very strange relationships, and people had used code from very odd places in the libraries simply because it was there. And so by removing these 6 methods, it actually made for a lot cleaner separation of the modules within the JDK itself. There was another class that was deprecated and had been removed in JDK 9. So this is the com.sun.security.auth.callback.dialog callback handler. Anybody think they used that? No. OK. I didn't think so. This was part of the Java Authentication and Authorization Service. It had been deprecated way back in JDK 7. So if you were using it, you would have seen a warning message every time you compiled your code or every time you ran your code. Again, some tooling to help you with this is to understand if you have used deprecated elements within the API, which ones have you used. So now there is this tool called jdeps, and it will do a static analysis of either class files or jar files and look at it compared to the standard Java SE APIs and tell you what things have been deprecated and what things you're using. So I created a very simple example where I used a bunch of deprecated things, and you can see the output of jdeps here, which says that I've been using the RMI security manager that's deprecated. As a class, I've got a couple of methods here that are being used, get selected values and things like that. So it gives you a report of things that you're using that are deprecated, and so then you can go and look at the code and decide whether you want to make changes or not. The structure of the JDK has changed. Now, the reason I'm including this in the pitfalls for the unwary is because some people may have used the structure of the JDK as part of their application. They may rely on certain files being in certain places in order for the application to work. If you've done that, because of the changes, it may stop your application from working. Prior to JDK 9, we had this concept of a JDK and a separate JRE, the Java Runtime Environment. And what you ended up with was the JDK directory structure that had a bin directory in it, which had a Java executable in it. And then you had a JRE subdirectory, which had a bin directory, which had a Java executable in it. So you actually got 2 Java for the price of 1. Now, that sort of made sense when we had JDK 9, because the idea was to enable you to have a smaller deployable runtime, only what you needed to run your Java application, not to actually develop it. In JDK 9, that's been flattened out. So now the idea is that with modules and the JLink command, what we can do is we can actually create a runtime specific to our application. So we have flattened out directory structure, bin directory that contains only one copy of Java. We have a lib directory that has all the native code. We have a jmods directory for the modules. And then we have a conf directory, which is new as well, where anything which could potentially be changed to configure the JDK itself is in that directory. The files used to be spread around in the JDK. Now they're all in one particular place. So the important thing is there is no more concept of a JRE. There is no more tools.jar. There is no more rt.jar. Version string format. Again, I'm including this for completeness because some people may have written applications where you parse the version string in order to determine which JDK you're using or which Java runtime you're using. And version strings in Java have been very confusing. Actually, again, I sort of went back and had a good look at this. And it turns out we had almost as many version string formats as we've had versions of Java. Because, for example, if you look at JDK 8 and you download Java SE 8 update 131, okay, well, that's kind of logical. If you do Java minus version, what you actually get back is version 1.8.0 underscore 131. So they've kind of added this one dot. And that was really because, right back in the beginning of Java, we had version 1.0. Then we had version 1.1, which was really wrong because it should have been 2 because there was some quite big changes. Then we had version 1.2, version 1.3, 1.4. Then we had Java SE 5. So we kind of lost the one dot. But in terms of the version number, they kept the one dot. So it was 1.5, 1.6, and so on. Also problematic is understanding which has more patches. So 7 update 55 or 7 update 60, which would you expect to have more patches? Well, logically, update 60 should have more. No, update 55 actually has more patches than update 60. Don't ask me why. We now have what hopefully will be the last ever version string format for the JDK. And they've come up with a nice way of doing that. So now we have feature, which is the major number, so that's like 11, 12, 13. Then we have interim. Interim is always 0. So you look at it and go, well, if it's always 0, why do we have to have it? And the answer is that that's reserved for future use. I suspect it's never going to be used, but it's there just in case they need it. So at least it is there. Then we have update, which has become more logical. Because if you look at JDK 9, the updates were numbered 9.0.1, 9.0. Well, you'd think it would be 2, but it wasn't. It was 9.0.4. And the reason for that was because they had to leave a couple of numbers in between if they had to issue an emergency patch. So that didn't really make a lot of sense. So now the update number is 1, 2, 3, 4. And if they need an emergency patch, then they've got another number at the end there, which is patch. Like I say, it's now much more logical. It's understandable by humans. You can parse it more easily. It's more semantic. Non-programmatic issues, things that might catch you out in JDK 9. Anybody here using Java Web Start? OK, no. So the first thing is not going to affect anybody. With Java Web Start in JDK 9, they changed the way that they parsed the launch protocol files and made it more strict. So there were some files that would have parsed in JDK 8 that won't parse in JDK 9. But since nobody's using that, we'll kind of move on. Another thing that's been removed because of the module system is the idea of the extension mechanism and the endorsed standards override mechanisms. These were both things that typically were used by app servers because they needed to load a whole set of classes before you started running your application. In the module system, these things have gone away, and so now if you have the libext or the libendorsed directory in your JDK, it will actually stop your JDK or JRE, Java Virtual Machine, from running. So if you try and do that, you'll actually get an error message saying, no, you can't do that. And certainly the ext directory, if you've done JNI coding in the past, you used to put dynamic or libraries for the platform in that directory. Don't try and create it in JDK 9 or later, because it will stop your JVM. Various other things got removed. We'll talk more about options later on. A whole bunch of JDK options for garbage collection got removed. There were things like the incremental concurrent mark sweep went away. The ability to do parallel new with serial old, that got no longer supported. So a whole range of different options no longer supported in JDK 9. Logging. Again, This is a thing that's quite important for people who use logging information in an application. In JDK 9, they switched to a unified logging system for the JDK itself. Rather than having different ways of logging from garbage collection, from threads, from memory management, whatever, it all uses the same logging framework within the JDK itself. And part of that is unified GC logging. Many people do actually parse GC log files in order to write tools which look at what's going on and see what's happening with the garbage collection. So it is important to think, okay, some of that might have changed, so your parsing may have to change in order to take that into account. Lots of flags have been removed from JDK 9, and most of these don't really affect anybody. In this case, they're just ignored. So it's not really a problem. You don't have to worry about them. You can just leave them there, and they won't have any impact on your application. You'll get a warning message, but that's it. Then there are a whole set of flags that have been replaced, and this is mostly to do with the unified logging framework. Things like printGC, which I know a lot of people do use. printGC details is also one that's very common. That's now been replaced with -xlog::gc or -xlogs::gc star, depending on what you want to do with that. As you can see, there's a whole set of other ones. Because these slides will be available later, I won't go through all of these. You can have a look at the slides later to see what the mappings are. Again, in terms of the warning messages you get from this, some of them will be quite useful. They'll say, okay, you've used printGC, that's deprecated, and the JVM will use the correct version instead, and it will warn you saying you should use -xlog::gc instead. Other ones will get a message like this: create mini dump on crash. It was deprecated and likely to be removed in future release, so use a different one instead. Then there are 50 command line flags in JDK 9 which have been removed, which will stop your JVM from starting. So you'll see unrecognized VM option could not create the virtual machine. That's the kind of thing which is going to require some changes in your startup script. So if you do things like print heap at GC, trace dynamic GC threads, these types of things, then you will actually get an error when you try to start your JVM. JDK 10. Right, what do we get in JDK 10 that might affect our application? Well, the first was local variable type inference. Nice, useful feature, but it does have a small impact. var is now a reserved type. It's not a reserved word, which is good because it means we can still use var as a variable name. What that means is we can do this. We can say var equals ArrayList of type string. That will work quite happily. But there is one thing that you can't do in JDK 9 that you could have done in JDK 8. Of course, nobody here would do what I'm going to show you. The reason is because we would never create a class called var with a lowercase v. That would be far too much like .NET. So what we do is we say, okay, now, because it's a reserved type, you can't create a class called var with a lowercase v. You can still create var with an uppercase v, just not var with a lowercase v. So that is one thing that could potentially catch you out on JDK 10, should you have done that. A few other things that have been removed from deprecation. So as I say, these are things where they're gradually doing some tidying up. The JDK security auth module, there's various things in there that have been affected. So com_sun security auth package removed a number of classes, mostly, well, as you can see, mostly to do with Solaris and X500. And then the com_sun security auth module package also had a couple of things related to Solaris removed from it. The Java Lang Security Manager, several things removed here. There was a field called incheck, and then a number of methods that related to some of the class loading things. But again, these have been deprecated for a long time. You would have seen warning messages about these, and my experience is that very, very few people have used them, if any. Java Lang runtime. So a couple of things that have been removed here. There's a couple of obsolete internationalization methods: get localized input stream, get localized output stream. Again, my experience talking to developers is that nobody has used these that I've come across yet. A couple of miscellaneous things. To do with JNI, the Java H command has been removed. And so now, if you've been using Java H to create the header files for your JNI code, you do it with Java C-H. Also, the policy tool, which relates to some of the security issues or security things, has been removed as well. Command line flags. Again, some things that have been removed here. So now we've shifted away from the idea of separate 32-bit and 64-bit JVMs. So from Oracle's perspective, there's now only the 64-bit version. So the -D32 and -D64 options no longer work. And then there are 5 -X options that have been removed. And I did look some of these up to see if I could figure out, I mean, I remember bound threads. I remember using that, and alt signals as well. But things like SQ no pause, I couldn't even figure out what that actually did. So it's probably unlikely that anybody's using that. If you do try and use one of those, again, you'll get an error message saying that the JVM itself couldn't be started up. JDK 11. What did we get in JDK 11? And because obviously a lot of people are thinking of moving to JDK 11 because it's a long-term support release, this is probably the one that cumulatively with JDK 9 and JDK 10 is most important. Well, the big thing with JDK 11 was Oracle made a decision about how they wanted to develop Java and how they wanted the Oracle JDK to relate to the OpenJDK. OpenJDK is the source code for the reference implementation of the Java SE standard. And in the past, the way things have worked is that the Oracle JDK uses OpenJDK, builds it all, and then they added a number of extra things onto that to create the Oracle JDK. Oracle decided that they were going to create 2 binaries. And the reason for this is to do with the way that they license them as well. So there is the Oracle JDK, which is the one that we all download from java.oracle.com. And that is now under a different license. From JDK 11, it's, rather than being under the Oracle binary code license for Java SE, it's under the Oracle Technology Network License Agreement. You can tell that the lawyers at Oracle are not very good at naming things. So they came up with this new license, and what that license says is that you can still download the Oracle JDK for free. You can use it for free in development, you can use it for free in testing, but if you want to put it into production, and the license classifies exactly what is production, then you need a subscription, Java SE subscription from Oracle. So to avoid the problems of Java not being free from Oracle, they created a second binary. And now, if you go to jdk.java.net, you can download a free binary from there, which is under the GPL v2 with class path exception license. Reason with class path exception is to protect you from the viral nature or the copyleft nature of the GPL license. If you ship your application with the JDK, then you don't have to provide people with the source code to your application. So this is under a different license, but it's only what you get in the OpenJDK. So what Oracle said was, right, we are going to eliminate any functional differences between the Oracle JDK and what you get if you build the sources from the OpenJDK. So this is where things do get quite important, because there are some significant differences between moving from JDK 8 to JDK 11. So there are some significant abs and features from JDK 11, things that you would have had in the Oracle JDK 8. So JavaFX, anybody using JavaFX? Nobody. OK. Well, JavaFX is quite an easy thing to fix. If you have been using JavaFX or you want to use JavaFX, it's quite an easy thing to fix because it is an open source project, OpenJFX, under the OpenJDK umbrella project. So you can still build the code. There are binaries that you can get either from a company called Gluon or from us at Zulu. We do a JDK 11 that's bundled with JavaFX if you want that. Browser plugin, that has gone away as well. So anybody who's using applets, I'm guessing there's nobody here using applets, then that has disappeared completely as well. So applet support is essentially gone from JDK 11. Java Web Start, kind of mentioned this earlier on, but nobody put their hand up when I asked if people were using that. What I have found is this is one that does catch some people out. There's still quite a lot of people out there who are using Java Web Start. And the problem is that Oracle haven't open sourced Java Web Start. There are some alternatives. So there's a thing from Red Hat called ICT Web, which does a very similar thing. There's also other projects like Install4J and GetDown. But none of them are a simple drop-in replacement for Web Start. There is some work required if you want to move from pure Java Web Start to any of those alternatives. Lots of tools have been affected in terms of the JDK itself, so all these things have been removed. It does make the JDK a little bit lighter weight, a little bit cleaner, so the applet view is gone, JControl, all the Corba tools like IDLJ, OrbD, server tool, tname serve gone. Java Mission Control is now available as a separate download. So although it was part of the Oracle JDK, and it has been contributed as open source, it's now a standalone package. Java Web Service tools for the JAX-WS, SchemaGen, WSGen, WSImport, XJC, and the deployment tools. And again, this is something that some people have been sort of caught out by. Java Packager, they are trying to build a new version of that, and Java WS. APIs that have been removed. So there's a handful of things that were deprecated and now being removed. Most of these, again, are not really too much of an issue. Things like Java Lang runtime, run finalizers on exit. There's this idea of trying to move away from finalizers. Thread.destroy has finally been removed, and also thread.stop, but only the one that takes a throwable as a parameter. The thread.stop, which doesn't take a throwable as a parameter, so has no parameters, that is still there for now, but it is deprecated. You shouldn't be using it. Other things that are a result of the change from having the Oracle JDK and OpenJDK, things like SNMP monitoring support, that was a sort of additional feature in the Oracle JDK. That's been removed. So the JDK.SNMP module is gone, and the JVM management MIB has been removed. A couple of things on the desktop side. The font rasterizer, the T2K font rasterizer, that's been removed. And the fonts are now relying purely on the fonts in the operating system. It used to be that there were some Lucida fonts that were shipped as part of the JDK with the idea that you had guaranteed platform-neutral fonts that would run or would look the same across all different platforms. That's now been removed because the whole idea of cross-platform is less important now. A few security certificates have been removed. Essentially, root certificates that have been removed to tidy up the trust store. Right, JDK 12. JDK 12 was probably it was the smallest release in terms of functionality. And so it didn't have a lot of impact in terms of the things that would catch you out. So only a few things have been removed. So ComSun AWT security warning has been removed. It was an internal API, not even used in the JDK. So I very much doubt that anybody is going to be caught out by that. Finalize methods have been removed from some classes. So file input stream, file output stream, zip file, and inflator, deflator. All of those had a finalize method. Now they don't. Again, I really don't think that's the sort of thing that would catch many people out. There is a root certificate that's been removed for the GTE Cyber Trust. If you are still using that, which is probably very unlikely, then that's no longer in the CA certs file either. And with the gradual move to newer releases, the Java-C compiler now no longer supports the ability to compile code directly for JDK 6. So the number of previous releases that are supported sort of keeps us moving forward. So when JDK 13 comes out, you would expect JDK 7 to stop being supported. Although I'm not sure if that's actually going to happen. We'll see. Just, again, sort of like tidying up things on command line flags. This is something that I looked at, and it was quite interesting to sort of do an analysis here. JDK 9 removed 82 -XX flags. That's in the runtime. And it sort of makes you realize just how many flags there are if you can remove 82 of them and nobody really notices. There are about 750, I think, in total. But they added 72 back again. JDK 10, they removed 18, added 20. JDK 11, 16 more removed, 34 added. JDK 12, 16 removed and 66 added. But 58 of those were for the Shenandoah garbage collector. So there's lots of different ways of changing that. And Chris Who Codes has got a really good website here. If you go there, there's a very nice breakdown. You can see all the different options for all the different JVMs and the differences between them. And also you can see a little bit of information about which each option actually does. So just to conclude then, basically if you're going to migrate to JDK 11 or JDK 12, then simple applications should run pretty much unchanged. Unless you've used any of the things that I've explained in the last sort of 45 minutes, then you should be able to take your application, leave everything on the class path, and just move it from JDK 8 to JDK 11, and everything will just work as if it was on JDK 8. Might have to make some changes to JVM command line flags if you started using some of these sort of more unusual ones, or even if you've used things like some of the logging things. Encapsulation, potentially an issue. If you are using things where you've got the internal APIs, then you might need to make some changes to JVM flags for startup to enable access to some of these internal APIs, or just leave everything using the big kill switch, and that will do the same thing. And using JDepreScan and things like that to analyze, or JDeps, to look at what your code's doing. That's probably a good idea as well. Smaller changes will have a slight impact, so there are more APIs being removed, and you just need to keep an eye on that. One thing I would say in terms of alternatives to the Oracle JDK, since I work for us all, I'm going to put this slide up and talk about our free distribution of the OpenJDK. So Zulu Community Edition, we take OpenJDK, we build it, we run all the TCK tests on it to guarantee that it passes all of those and is completely compatible with the Java SE specification. We have many versions of it available. We actually currently go back to JDK 7, 8, 9, 10, 11, and 12. Not sure if we actually got a 13 early access build available at the moment, but we certainly got 12 up at the moment. We have nice wide platform support, so you've got 64-bit for Windows, Linux, and Mac, 32-bit for Windows and Linux if you want to run on older versions of those, and we also have ARM32 and 64 if you want to run it on something like a Raspberry Pi. Commercial support is available at a very reasonable cost if you want it. Feel free to talk to me about that. And you can get that, as I say, for free from azul.com, downloads Zulu. And that's it. So thank you very much.